Hello, I'm Geoffrey Litt, a PhD student at MIT, and today I want to tell you about a new way for end users to customize software without doing any traditional programming. And this is joint work done with my advisor Daniel Jackson at MIT, as well as two undergraduates, Tyler Millis and Jessica Quaye. One of the great things about the web is just how malleable it is. I can install browser extensions that make all sorts of useful customizations to websites that I use every day. I can even dive into the browser developer tools and restyle a website or run arbitrary JavaScript on the page. But there's a problem with all of this, which is that all of this malleability, it's only accessible to programmers. If you're a typical end user who doesn't know how to program in JavaScript, you can't create your own browser extensions or customize websites really at all. So this raises the question, can we find some way to enable end users to customize websites in a more lightweight way as part of their everyday usage of the web? This is a problem that many projects in the past have tried to explore, and today I'm going to show you a new approach. I'll demonstrate to you the system we developed called Wildcard, which is a browser extension that lets end users modify real websites in useful ways. But in addition to showing you the system, I'm also going to talk about three ideas that are embodied by the system, which I think are useful ways of thinking about software. First, I'll talk about how empowering it can be for software to be customizable by direct manipulation rather than by writing traditional code. I'll also talk about how we can make customization a lot easier by creating semantic wrappers around existing software that expose higher level meaning. And finally, I'll talk about how I think this work may suggest a path towards breaking down data silos and taking back more agency over our data. All right, let's start at the beginning with customization by direct manipulation. This diagram sums up the main problem with software customization today, which is that as you increase the power you want for tailoring your software, there are these sudden cliffs where you have to invest a lot in developing new skills. And in particular, there's the biggest cliff of all, which is going from being just someone who tinkers with software to being a programmer who can deeply customize their software in some sort of full programming language. A better approach than this is a smoother slope, where there are many different techniques, and each one only requires a small incremental increase in skill. So what does this look like in the context of the web? Well, we propose a new technique called data-driven customization that helps to span this gap. And here's how it works. We start out with the original UI of the application, and next to it we introduce this table view, which shows some of the essential information from the UI in a table form. Now beyond that, we also keep the user interface and this table bidirectionally synchronized. And what that means is that the user can manipulate this table as a means of customizing the original application. Let me show you an example. This is the grocery website Instacart, which I've been using to buy groceries online. And the other day, when I was finalizing one of my orders, I wanted to sort my items by price so that I could audit the most expensive items at the top of the list. Now, the Instacart website doesn't have any way of sorting my items at all, but let me show you how I was able to do it using Wildcard. So here's my grocery list. You can see it has a bunch of items in it, and when I open up the table view, you'll see that each of these items has a row in the table. And as I click through the table view, the system shows me how the table and the original page correspond to each other. Now when I sort by the price header, it sorts the table but also the original web page. So now the items in the page are sorted by price as well. At this point, I can just close up that table and continue browsing Instacart using their original user interface, but with the items sorted. Now it's worth pointing out, sorting is a very familiar direct manipulation interaction. I was able to just see the relevant data, click a button, and instantly see the results. However, we were able to use that interaction to perform a new customization that was not part of the original web page. So this shows how direct manipulation can be a powerful customization technique on a real website. Let me show you another example of how sorting is useful. I was shopping for books at a book sale, and about half the books were sold out, which was really frustrating because I had to sift through all these entries. I can use a similar approach to fix the problem with Wildcard though. I can open up a table that has a sold out column and a row for each book. And then I can just sort to put the books that are still available at the top of the list. Then I can close up the table and go back to browsing the original website UI. Now, coming back to our diagram, we can see that basic interactions like sorting are pretty low on this curve, but nevertheless, they do let us implement useful customizations. Next, let's move further up the curve to a more sophisticated technique of spreadsheet-style formulas. I often read the Hacker News website, and I've noticed that the longer, more in-depth articles tend to be my favorite ones. And so I wanted to add estimated read times into this website and also put the longest reads at the top. Let's see how I can do that using a spreadsheet formula in Wildcard. So I'll open up a table, which once again has one row per article on the page with attributes like the link and the number of points. I can sort as before, but this time I'm going to enter a spreadsheet formula. This calls a function called readTime in seconds, which calls an API to fetch the estimated read time for that URL. Now I'll enter another formula to turn that seconds number into minutes. Looks like I should round to get nice whole numbers. And then at this point, I can just click a button to show those values in the context of the original page. Now it's a little hard to understand just a number like that, so I can edit my formula to add a label. And finally, I can sort by the numeric column to put the longest reads at the top. And just like that, we have read times integrated into Hacker News. So what that illustrates is that spreadsheet formulas are capable of producing more sophisticated customizations in this tool. Now, it's a little debatable whether spreadsheet formulas really constitute direct manipulation, but I think it's certainly the case that writing code in a live visual environment like this, combined with a pure semantics of a formula language, is certainly easier than writing normal code, as illustrated by the millions of people who use these kinds of formulas in spreadsheets every day. Now, there are lots more examples in the paper of other customizations you can make. We've validated this approach on about a dozen websites so far, and you can look in the paper for more details on this. Now, you might be wondering, how does all of this actually work? Where does that table come from? And to address that question, let's turn to the next idea of semantic wrappers. A lot of the utility of customizing in the browser comes from the fact that you can modify the DOM, which is this transparently exposed, unofficial interface to an application. You don't need to wait for a website to expose some sort of official plugin API. You can just go ahead and implement all sorts of changes that the original website authors didn't expect or intend to support. You can even do things that they try to prevent you from doing, like ad blocking. The problem with this is it's quite a low-level interface, so it's very difficult for end users to grapple with, things like directly editing HTML. In some sense, you're reverse engineering the application. So how can we preserve this notion of unofficial customization that doesn't depend on the original website authors, but at the same time expose a higher level interface that's easier for end users to work with? That's where semantic wrappers come in. In the case of our system, we show this table view that extracts key information from the page, and we have a wrapper layer that maps from the DOM of a website to this table. Now, these wrappers are coded and maintained by third-party programmers, and they're contributed to a shared ecosystem where any end user can use a wrapper once it's been created. The Wildcard tool provides a framework that makes it straightforward for programmers to write these wrappers, and basically turns it into the task of writing normal web scraping code. With this approach, you can still make unofficial customizations that don't depend on the original websites doing any work, but you also get a higher level interface so that end users can customize without getting involved in messy lower level details. Now, it can be a challenge to maintain these kinds of wrappers externally over time, but there is a helpful factor here, which is that a single wrapper can be used for many different kinds of customizations. That's quite different from the typical browser extension, which tightly couples scraping logic with a very specific feature set. These wrappers are generic, which means that more people might be invested in helping to maintain them. I just want to mention that this isn't a new idea. There's been lots of prior work on this sort of thing, including fancier techniques like automatically generating these wrappers or helping end users create them. And we are considering future work in that direction as well, but for now, we just have programmers write the wrappers. All right, let's move on to the next idea, decoupling data from applications. In the traditional world of desktop computing, everything revolved around files. You could manage files yourself, open them in multiple applications. But these days, things are changing. As things move to the cloud, a lot of data is getting centralized in data silos, where an application and its data all get bundled together, and you can only access the data through that single application, whether that's Google Docs and Apple Notes, or Facebook and Twitter. And as a result of this, we've lost a lot of control over our data, as well as a lot of interoperability between applications. Now, there have been some interesting proposals for remedying this, with more decentralized architectures that give users more control of their data. For example, last year at the Onward conference, there was a talk on local first software, and Tim Berners-Lee and collaborators have also been working on the Solid project, which are both very inspiring directions. But I think there's a challenge, which is that these projects represent a large shift in how the web is architected. And in contrast, I think that our Wildcard project suggests a more incremental path towards this kind of vision that works together with the existing web. Let me show you what I mean. Starting with some website, we can extract data from that application using these semantic wrappers, but then we can also augment that with additional local data that's stored in our browsers. Let me show you an example. Back on the Instacart grocery website, I had the desire to jot down notes on my grocery list, just like you might on a paper grocery list. Now, Instacart, again, didn't have this feature built in, but I was able to do it with Wildcard. So I open up the table, and this time I'm just going to type some text into this additional column on the right-hand side, like I might in a spreadsheet. And you'll notice that the text appears in the original web page. So this is serving as sort of an annotation mechanism. But in addition, these annotations are actually persisted in my browser. So even if I go and refresh the page, when I come back, those annotations will show up just in the same place that they were before. And I didn't need to wait for Instacart to develop some sort of annotation feature, but I also didn't need to send Instacart this data at all. I was just able to store it in my computer. Now, I don't have time to get into the details of the implementation in this talk, but I'll show you just a brief glimpse of how this all works under the hood. We've had this idea of a table adapter, which is an abstraction that exposes some resource as an editable table, which helps implement the demo I just showed you. So in this diagram, we have two table adapters. The first one is the DOM scraping adapter, which interfaces with the original web page DOM and exposes that data as a table. This is the part that handles bidirectional syncing between the table and the DOM. Now you'll notice this adapter exposes a table that has an ID for each row, and these are ideally tied to some sort of server-side persistent ID. There's another adapter called the local storage adapter, which is simpler. This just exposes some part of the browser's local storage as an editable table, and you'll notice when we make those annotations that we also record those IDs in that table as well. Now to produce the final result, we can just do a simple join to sort of map across those two tables, and that produces the final result that the user sees. This is a fairly generic mechanism that could be extended to do other kinds of things. One example is, beyond augmenting with local data, could you use this mechanism to sync data between different applications? Or maybe I could share that column of annotations with another user directly via some peer-to-peer mechanism. We haven't explored these yet, but we're interested in exploring them in future work. So to recap, today I've shared with you the Wildcard browser extension, which enables end users to customize websites without doing traditional programming. And I've also talked about these three ideas, which I hope might nudge you to think about software differently in the future. Thanks for watching. If you'd like to get more information about this system, you can read the paper and get further updates at this URL right here. Thanks so much, and I look forward to hearing your questions.